Good morning, everyone. So today we're going to be talking about section 3.8 in your textbook, in your geometry textbook, parallel and perpendicular lines. And so let's just get started by talking about what parallel lines are. We've been talking about them in class, and we did basically define parallel lines as lines that never intersect. So they're never going to touch, but they have to be in the same plane. Because there are lines, remember we talked about skew lines that never intersect, but they're not on the same plane. So parallel lines, lines that never intersect, we use the symbol this to indicate like A is parallel to B, so the two lines are parallel. If we see it in a proof, we're going to definitely go ahead and mark our diagram with the arrowheads we talked about. But in recent days, we've been talking about the slopes of lines and linear equations. And so what do you think is true about the slopes of parallel lines? I mean, if the lines are going the exact same direction and they never intersect, I'm hoping that you would say to yourself that the slopes would have to be the same. They have to have the same slopes. So parallel lines have the same slopes. Say that to yourself. Parallel lines have the same slopes. Out loud. I can't hear you. Okay, so what do you do to determine whether the graphs of y equals negative 3x plus 4 and 6x plus 2y equals negative 10 are parallel lines? Well, in order to tell if linear equations are parallel, you have to compare the slopes. The easiest way to compare the slopes is to put them in y equals mx plus b. Why would you want to do that? Well, because you can see the m, and m is the slope of the linear equation. So the first equation I see is already in y equals mx plus b, and it has a slope of negative 3. All right, so let's try this next equation. Let's put it in y equals mx plus b. So we've got 6x plus 2y equals negative 10. So I'm going to isolate y. I'm going to solve for y. So I'm going to subtract the 6x to the other side, and I'm going to put it in front. So I'm going to do 2y equals negative 6x minus 10. Then I'm going to divide every term by 2. Okay, so actually I have to go over here, sorry. So I get y equals negative 3x minus 5. All right, so let me compare the slopes. I have a negative 3 in this one, and I have a negative 3 in this one. The slopes are the same, so the lines are parallel. So I would write lines are parallel. Okay? All right, now I want you to try. So press pause on the computer. You try with the next two lines, and then turn it back on and see if you are correct. All right, so you're back, and you have put the first one in y equals mx plus b, which is, let's see, negative y equals negative 3x minus 5, making sure you put the x in front. You have to divide everything by negative 1 to make it positive y, so y equals 3x plus 5. And in the other equation, I'm going to solve for y. So let me switch colors. I get 5y equals, I'm going to add the 15x to the other side. So I get 15x plus 10. Divide all the terms by 5. And I get y equals 3x plus 2. Okay, so in this case, I look at the slopes. I compare the slopes. The slopes are both 3, so lines are parallel. Okay, so let's move on. Let's put it all together. Write an equation of a line that is parallel to y equals 2x plus 5 and passes through the point 0, 6. So let's just remember that in order to, the minimum you need to write an equation of a line, the minimum you need is a point and a slope. That's the minimum. All right, so right now, to write the equation of a line, I have a point. I actually have a very special point. I want you to identify that point. That is the y-intercept. Okay, so my line has a y-intercept of 6. And my line is parallel to this line. So we have to borrow the slope. If they're parallel, that means they have the same slope. So my slope would have to be 2. Because the slope of this line is 2, and it is parallel to that line. All right, so now I have a slope, and I actually have the y-intercept. So to write an equation of a line, I'm going to use slope-intercept, which is y equals mx plus b. I'm going to plug those values in. So y equals 2x plus 6. So far, so good? Yay! We've got it. Let's move on. All right. You try this next one. This one's a little bit harder. So I want you to see what you can do with it and then come back to us, okay? All right, so you're back. And actually, I'm going to give myself some room here. Okay, so it says write an equation of a line that's parallel to 2x plus 6y equals 12, and it passes through the point 1, 3. Okay, so remember, my minimum I need is a point and a slope. Okay, I have a point, 1, 3, okay? Noticing that's not the y-intercept because x is not 0. And I have an equation, so I have to find the slope, so I can borrow the slope. So to find the slope, I have to put it in y equals mx plus b, right? Right? Okay, so I'm going to solve for y. So I get 6y equals, I'm going to put that x in front. So it's in mx plus b form. I'm going to divide by 6. And I get y equals negative 1/3 x plus 2. All right, I'm going to borrow the slope. So the slope has to be negative 1/3. All right, so now I have a point and a slope. So I've got my minimum, but the decision now is which equation should I write? Should I use y equals mx plus b, or should I use point slope? I use y equals mx plus b if I have a point and a y-intercept. I use point slope if I have a point and a slope, right? Point slope. I know, I'm funny. All right, so I'm going to use point slope, which is going to give me y minus 3 equals negative 1/3 x minus 1. And I'm done. Not too bad, right? All right, let's talk about perpendicular lines. Oh, we love those, right? Perpendicular lines, as a reminder, are lines that intersect at right angles. Okay, you guys have gotten good with the perpendicular lines. Remember, the symbol for perpendicular is an upside down T. If we know that lines are perpendicular, like if I say that these two lines right here are perpendicular, then I put a box indicating that they meet at a right angle. Another way to say lines are perpendicular, though, is to say that their slopes are negative reciprocals of each other. Okay, so if negative just means it's the opposite. We can also say opposite reciprocals. Reciprocal means the flip of it. So if I tell you 2, reciprocal would be, because 2 is over 1, I'd flip it. It would be 1/2. If I tell you 1/2, the reciprocal of that would be 2. All right, so let's make sure we understand that. If a line has a m, or a slope of 2, a line perpendicular to it is going to have a slope of, okay, so I take the opposite, so negative, and I flip it, reciprocal, so 1/2. Okay? All right, if a line has a slope of 1/3, a line perpendicular to it has a slope of, all right, we make it negative and we flip it, so negative 3. All right, if a line has a slope of negative 2/5, so it's negative now, a line perpendicular to it has a slope of, okay, so we do its opposite, we make it negative. So if it's already negative, it's going to become positive, and we flip it. So my slope would be 5/2. All right, here's I put a star here because this one's kind of funky. A line has a slope of 1. A line perpendicular to it has a slope of, all right, so we make it negative. We do its opposite sign, and then we flip it. When we flip 1, it's 1/1. We get 1. So a line, if it has a slope of 1, a line perpendicular is going to have a slope of negative 1. All right, so hopefully you understand the concept of negative reciprocals or opposite reciprocal slopes. So perpendicular lines, again, have opposite reciprocal slopes or negative reciprocal slopes. All right, so how do we tell if lines are perpendicular? Just by looking at their equations? Well, we do the exact same thing that we did with parallel lines. We compare their slopes. Let's do that. We compare slopes. All right, so in order to compare their slopes, we need to put them in y equals mx plus b. Okay, so this first one, I'm going to put the first one in y equals mx plus b by solving for y by dividing all of the parts by 3. And I'm going to get y equals 3x plus 1. All right, the other equation, let me switch colors. I get 6y plus 2x equals 6. All right, so I'm going to solve for y. So I get 6y equals negative 2x plus 6. I'm bringing the 6 to the other side. And now I'm dividing by 6. So I get y equals negative 1/3 x plus 1. Okay, so I compare the slopes. So this one has a slope of 3. This one has a slope of negative 1/3. Are they opposite reciprocals? They are opposite reciprocals, so we could say the lines are perpendicular. Remember, they have to be opposite reciprocals to be perpendicular lines. All right, now how do we put all this together? Well, I could say to you, write an equation of a line, okay, containing the point 1, 2, and perpendicular to the line y equals 3x plus 1. All right, so let's review. That minimum that we need is a point and a slope. So even write it down for yourself. Those are what you need. All right, so I have my point. I need my slope. Well, if it's perpendicular to this line, I'm going to borrow the slope. I'm going to borrow the negative reciprocal slope. I'm going to borrow the negative reciprocal slope. So I'm going to take this slope of 3, and I'm going to take its negative reciprocal. So it would be negative 1/3. All right, so now I have my point, I have my slope. Best equation to use at this point would be point slope. So I plug it right into point slope, and I get y minus 2 equals negative 1/3 times x minus 1. And there's my equation of my line. Okay, let's try another one. You try the next one, and then come back and let's meet. All right, so you have tried it. Let's see what we got. All right, so my minimum, again, is my point and my slope. I have a point. I need a slope. Write an equation line that contains the point negative 2, 4, and is perpendicular to y equals 2x minus 3. It's perpendicular to it, so I need to borrow the negative reciprocal slope. So if this slope is 2, I need to borrow the negative 1/2 slope. Make it negative and flip it. All right, I have a point and a slope. This point is not the y-intercept, so I'm going to use the point-slope equation, which would give me y minus 4 equals negative 1/2 x. Now, because it was a negative 2, this is going to become plus 2. Okay? All right. Last thing to cover that I want to talk about is the term perpendicular bisector. Okay? We know what the word bisect means. It means cuts it into 2 equal parts. And we know what the term perpendicular means. It means things that meet at a right angle. So a perpendicular bisector of a segment, okay, is going to be perpendicular to the segment and cut it at its midpoint. So perpendicular to a segment and cuts it at its midpoint, or cuts it into 2 equal parts. So this segment right here is a perpendicular bisector. All right, we're going to be talking about that more in class in the coming weeks. All right, so again, let's just recap a little bit. Parallel lines have the same slope. Perpendicular lines have the negative reciprocal slope. But now what I'd like you to think about are those special slopes that we know. Remember those special slopes? Remember Hooy-Vux? What would be perpendicular to a vertical line? What would be perpendicular to a vertical line? I hope you're saying that a perpendicular to a vertical line would be a horizontal line. Okay? So a vertical line, if I ask you what's perpendicular to it, it would be a horizontal line. So what if I told you the slope was undefined? Something has an undefined slope. What would the perpendicular slope be? Well, undefined means something like this, 1 over 0. If I flip that, I get 0 over 1, which is 0. So if a slope is undefined, its perpendicular slope would be 0. And that makes sense because a vertical line is perpendicular to a horizontal line. All right, we're going to be talking about that and practicing that in your classwork and homework in the coming days. So definitely something that you're going to want to keep in the back of your head. That's really, really important. All right, guys, I hope you had a great day. Talk to you tomorrow. Bye.